So the two-piece brake does work, and the brake can be engaged without moving the telescope, and there is enough braking power to hold my 5-inch refractor still when I take out my heaviest eyepiece. The two-piece brake consists of the brake mount section. It attaches to the mount through the stock brake screw, and this gap is precisely over the gap between the altitude axis and the stationary part of the mount. You can actually slip a piece of paper through here and it'll go all the way into the mount. That's how precise it is. The width of this was chosen to fit in that space between the ridge that's on the mount and the gap. I certainly didn't want to cover the logo, the feather, so aesthetically the width of this was chosen for that reason. The width of the brake is then the entire width from the gap over to where the saddle is. That way it has maximum braking power. The components of the two-piece brake are the two pieces, okay, held together by a 10-24 socket head. There's two of them, okay, and there is a thin washer between the two so that there is actual gap, so there's not friction between the two things. So there's a spacer, okay. The screws are at 4 and 8 o'clock, so it's 120 degrees between here and here, here and here and here and here. So there's like equal holding here. So when the brake is closed at the top, it comes together equally, and that was the fix for the telescope moving. It kind of has to be like this. I suppose one could be at 6 o'clock, but I don't know. I like the two-place holding thing here. I think that's nice. The diameter of all of this is 102 millimeters. There is 1 millimeter thick felt on the inside of it all. I cut the two strips of felt, to be this wide and that wide, and stuck it to the inside. And it was actually quite easy to do. I bought 1.5-inch wide, 1 millimeter thick felt from a supplier with adhesive on the back, and it was easy to cut to the length. It's about 12.5 inches in the length. I cut it and stuck it in here. It's actually very, very easy. It's very easy to even align to the edges. It was easy to assemble. The clamp part, the cam lever part, there is a cam lever here. There is the part that holds it to this tine. There is a thumb screw here. I like the thumb screw because you can really adjust it very easily. And I put a vinyl washer between the thumb screw and this tine. The thumb screw is really nice because you can adjust the tension on the brake. A heavier telescope needs a little more tension, and this thumb screw makes it easier than the original socketed screw I had tried here. In between the two, I think this is kind of cool. I got a spring. There's a spring in here. I found a spring that fits in there, and the spring keeps the tension of the thing open, so that the friction on the telescope, on the mount, is the least possible when it is open. I want outward force, so the spring provides that when the thing is not engaged. But the spring is very compressible, so it operates fine. There's no there's no impediment to operating the brake, because of the spring. But the spring keeps the thing open when it's disengaged. Okay, the brake can be, engaged down and disengaged up. I like that for storage. I'm going to store a telescope on my mount. I'm going to let it sit there. This is the engaged, braking force. You can also do it the other way. The thing allows you to have it disengage this way and engage that way just by turning the thing around. So when I'm observing, I like to just flop this down for the brake off, and then I put it up for the brake on. So I think for observing, I use it this way. And then for storage, I use it this way to clamp, and this to unclamp. I don't know, I just like it that way. It's very versatile. You can turn it around, and, you can adjust it here very easily. So I think the binary on-off thing is actually pretty cool. When the brake is disengaged, there is a little bit of residual friction from the felt touching the altitude axis, at the mount. But it's very little friction. And as my conversation with Rowan, implied that the extra friction does not put any undue stress on the mount. An alternative design, which would have to be done by someone who could machine Delrin, I suppose, would be to have this be 100 millimeters in diameter, basically exactly what the mount is, or ever so slightly more, and that would result in probably a more binary break off, break on thing. There wouldn't be the felt in the middle creating a little bit of drag. When the thing was disengaged, there'd be no touch. It would be friction free. And then when the thing was engaged, it would just stop down on the altitude axis. So I think if this could be made by somebody who can machine Delrin, I think that would be maybe a little better than this. The 3D plastic printing thing creates a nice durable part. But the inside is not, as smooth as machine Delrin would be. So here is the brake on the mount. You'll see that it starts where this ridge is, doesn't cover the logo, and it goes all the way over to where the saddle is. I mean, just about. I don't want it to be flush, but it's close. And this gap here is aligned right over the gap between, the mount and the altitude axis. It's held down by the stock screw. I leave the brass thing on it basically so that I don't lose it. It's basically stored inside the mount, and since it's lifted up off this, it never engages. So it basically goes in and it attaches to the top of the mount just like that. You want it nice and tight, okay? So there we are. Here is my 8-inch SCT. I have my heaviest eyepiece. It's a 21 millimeter ethos in the diagonal. This is balanced. There is no friction on this dialed in at all. On the friction lock, it's completely off. All right. So with the brake off, and this thing is free floating. All right. So if I take the eyepiece out, it obviously tips over. Okay, so we'll put that in here, and I'll put the brake on, and then I take the eyepiece out, and it stays still. So it functions as an eyepiece lock quite easily for this 8-inch SCT. Here is my largest telescope. It's a 5-inch Teleview NP127. It is also balanced with my heaviest eyepiece. Okay? And the friction lock is off. Now normally there'd be some friction in here so the motors would engage and the slow motion controls would engage, but I'm testing this like worst case scenario, no friction here. Anyway, so you take the eyepiece out, and there it goes, and put that back in there and put on the brake, and take the eyepiece out, and it's stubborn, there we go, and it stays still. So the brake even works with my longest telescope with my heaviest eyepiece. Now I know that the AZ100 can take a much longer telescope. I can't possibly test that, but the brake can be designed in such a way where the clamping forces can hold probably anything still. So just by maybe a redesign or Rowan perfecting this, this is just a proof of concept thing. I'm hoping that Rowan likes it and then does something with the design and makes it their own. I've been in contact with them a lot over the last 6 weeks or so. This is the 5th version of the brake, and I think it's ready to be maybe tweaked more than I can tweak it. Ways to improve it would be to, I think, make it machined out of Delrin. That way it could be smooth on the inside. You could make it the same width as the axis diameter, and then it would slip over without any felt needing to be there. It would be it would be more binary. You would open the brake, there'd be no friction at all. You'd tighten the brake, it'd be lots of friction, would hold it still. So that would be one way to perfect it. I think machined Delrin would be ideal for this. Another way it could be perfected would be to maybe design a cam that has a different kind of throw. This is something I got at McMaster. The amount that it opens and closes the caliper, I think it's 3/64 of an inch. It's like a standard, cam lever. I'm sure one can be engineered so that the throw could be much more. You'd open it, it would open, and then you would close it and it would clamp. So if this had a greater range of opening and closing, it might work, even better than this does, although this works great, but maybe a longer telescope would need a longer throw cam lever. All right, but I think this basic design works for me, and I think in the hands of someone who can do it better than me, then again, maybe machine Delrin and better parts and all that, then I think someone like Rowan can improve on this and make it their own. I've been speaking with Derek a lot over the last month, and I've sent him videos of prototypes and all that sort of thing, and it's gotten to this, and I think this is a good design with which it can be made a little bit better.